All right, so today we're going to talk about sum and difference of cubes. So what happens is when we have two terms and we have a perfect cube, meaning something times itself a third time will equal this item, plus or minus another perfect cube, then there's a certain formula or process that we can follow in order to factor that. So in this case, we have 125x to the third plus 64. Now what I think would be easiest to do is to write out what does A actually equal and what does B actually equal, so that this makes it easier to plug this kind of in our formula in the process. I know the formula looks confusing, but honestly once you do this a few times, it's pretty easy. I think you guys will find that this isn't too bad. Now the first and most important thing is figuring out what is A and what is B. A is going to be what item, what monomial multiplies to itself 3 times to get back to your original. So what times what times what is 125? Well, that would be 5. 5 times 5 is 25, times another 5 is 125. Now, what times what gives me x to the third? Well, that'd be x. So it means that A is the entire 5x. So A is 5x. B now, what times what gets me 64, and that is 4. What you may not know is that in your calculators you can plug in the cube root of 125 and plug in the cube root of 64 to see what that equals, and your calculator will give you that answer. Now, given A is 5x and B is 4, we're going to follow this pattern and we're going to plug it into these two sets of parentheses here. So our first step is we have in parentheses A plus B. Okay, well A is 5x plus B, which is 4. Not too bad. One thing I want you to notice is that these have the same sign. That'll always be true in both formulas. We're going to have the same sign. Then in our next set of parentheses, we are given A squared. Well, A is 5x. So what is A squared then? Well, 5x times 5x is 25x squared. So 25x squared. Notice how it's minus. That's just part of the formula. So minus A times B. Well, 5x times 4 is a 20x. So minus 20x. And then again, plus. So one thing I want you to know is that from here, this is always going to be the opposite sign. So opposite sign. So same sign, opposite sign, and then this is always positive. So always positive. Now, how do we find that? Well, we take B squared. So B is 4, meaning B squared, or 4 times 4, is 16. And this is it. That is the answer. So given that we have something in the form of A cubed plus B cubed, in this case, 125x to the third, plus 64, we can then say when we factor this, we get these two factors, 5x plus 4, and then times 25x squared minus 20x plus 16. We're going to go through the same process with this next problem, and you'll see that our first signs are always going to be the same, the next signs are always going to be opposite, and your final sign is always going to be positive. Let's follow the same process here with number 2. So first, what is A and what is B? Notice how they're separated by a minus sign. It's just part of the formula. So A is going to be 3x, because 3 times 3 times 3 is 27, and x times itself 3 times is x to the third. Now B, be careful, B is 1, not a negative 1. The minus is part of that formula. So B is 1. So 1 times 1 times 1 is also 1. Following our pattern, we're going to have the same sign, right? So if this is a positive, we would use a plus sign. If that's a negative, we'd use a minus sign. So A minus B. So we get 3x minus 1. Now, remember here, the signs are going to be the opposite. So if I have a minus sign, my next sign is going to be opposite, which in this case is positive. So following the formula, we have A squared. So we're going to square our first term. 3x times 3x is 9x squared. And then plus A times B. Well, 3x times 1 is just 3x. And then our last term is always positive. And so 1 squared, or 1 times 1, is 1. So this is a positive 1. Now again, it seems confusing at first. I know I did that kind of fast. You can always pause, rewind, and go back. But after you do 2 or 3 examples on your own, you start to notice a pattern, and then it actually doesn't matter in terms of memorizing this formula versus this formula because the process is the same.